how to integrate or how to set up both BigIP and NGINX, and what is F5 doing with our Ingress strategy and our Ingress solution. And so it's actually great that I get to communicate with you folks as a PM for F5 with Kubernetes and OpenShift Ingress, specifically with BigIP and NGINX, the two groups, and as how we work together to provide a solution that simplifies this world of integration, specifically in the containerization space, is actually really important. So please, today, no question is silly, no question is off limits. I'd love to get some feedback, and if you want to follow up with some more deeper whiteboarding and discussions, please let me know as well. It's completely available to you. I also have a lot of content, and I'm not going to go that deep into this content today because there is quite a few pieces of the puzzle. But what we're going to do is we're going to take a look at the overall architecture, take a look how these components communicate together, and talk a little bit about the strategy and kind of where we're going. Both of these projects are very, very active, as you can see. We also have some polling questions that I'm going to go ahead and poll. And the polling questions is really just to get an idea of kind of where you are as a community. And then we'll go ahead and kind of cover those questions, and hopefully that will generate more questions, because I will definitely keep quite a bit of time to the end to provide more collateral, to provide some resources, etc. And that's where I think the community asking the questions is actually quite important. So when we first took a look at BigIP Ingress, or BigIP plus container Ingress, and NGINX, we asked ourselves a couple of questions. And our biggest question to ourselves is, how do we simplify Ingress and provide a cloud-like solution? It's almost like that one-click solution that makes potentially deploying something either on-prem or completely platform agnostic. How do we simplify that with utilizing potentially the best of what F5 has to offer by leveraging these technologies, and also address and align specific needs? And we're going to talk about those needs. And, I do talk to a lot of customers, and I am seeing it. I'm very active, and my team is very active in the community. And we do see the challenges. And some of the biggest challenges that we see is potentially classic BigIP being either a virtual or a physical appliance. Classic BigIP is today, in this instance, in this environment, outside of the cluster. That means it's outside of OpenShift, and it sits outside of Kubernetes. But that is not necessarily a bad thing. It's been deployed, if you think about it, for years, right? With application logic, these applications are verified and certified to run on this platform. Now, how can you leverage what you've done in the past to be able to utilize for potentially a Kubernetes or OpenShift environment? With also try to mitigate the new challenges that you're going to see when you start bringing on different organizations or potentially different personas, the NetOps versus DevOps play. And if you look at the solution, F5 and NGINX, I think it aligns really well with that NetOps and DevOps play. How do you coexist or cross-line? And we're going to start to talk about some of the new and interesting concepts that I am seeing with potentially some new personas. I'm going to map these personas out. And again, you're welcome to use this, because this is what's coming from the community, from what I see through all my discussions with the community, as well as with our sales organization and customers like yourself. So When we sat down about a year and a half ago in a room in Seattle, and it was the stakeholders from NGINX at the time and a lot of the sales group, the biggest challenge was the complexity with container applications or container environments. How do we operationalize it? And how do we simplify it? Significantly taking these requirements and aligning these requirements with the priorities from the different teams. We're seeing, and you probably see as well, that the priorities between maybe NetOps and DevOps are somewhat different. And how do you take these priorities and kind of align them together, build an architecture or a solution that can potentially help by streamlining certain processes? And I think this solution really, really helps in that situation. And when I go to the persona, it's going to break it out. We have multiple sources of truth here. There's a source of truth on BigIP itself that is generated within Kubernetes. There's a source of truth between NGINX. There are multiple APIs, whether it's the infrastructure APIs, whether it's potentially some security APIs. So the biggest thing for us is standard and common APIs, with the premise of not breaking those APIs. Those APIs are contracted, and the API that BigIP uses to orchestrate from Kubernetes is just that. It is contracted not to break the API. We do update the schema, but we don't change the API, and that's really important. And some of the other aspects as well. So common API type questions is very much key. What we've used here is a common CRD between NGINX and CIS, or BigIP. Think of it as Kubernetes automation or orchestration. Obviously as well, multiple sources of truth with GitHub repos, Bitbuckets, etc. What's also interesting is in these environments, the BigIP UI, the NGINX UI, we've got Kubernetes UI, OpenShift UI, we've got multiple UI and UXs, different Ingress resources. So by standardizing, and I'm sure probably a question is like, why don't we do this for OpenShift routes? Why don't we do this for something like an Ingress resource or Ingress class, etc.? And the reason is to try and standardize. Potentially, maybe later, to build some type of Helm or build some type of operator. I think that would really remove any type of different UI or different Ingress resources and just simply just deploy this as an operator. This is interesting because if you look at Ingress Link and this solution that simplifies, that cloud-like one checkbox is really uncustomized. Once you start requiring customization and advanced configuration of BigIP, now you somewhat come and go out of that box. And so highly customized solutions, potentially that require, high degree of subject matter experts, yes, that can be done. But again, you're making the solution a little complex. And I understand that because, again, those potential apps are certified on that platform. And maybe they do require some complex objects, or maybe they do require some additional security. Maybe it's your application security that is required. And again, that can be done. And that is where kind of like this discussion can go. And so maybe it's just simplicity to start, and then we start adding on the different pieces. So I really want to focus today on aligning the needs of infrastructure security and apps. And that's really where we want to go. So what we did with our think tank and our discussions before we started building this is we came together and said, we want to coexist. We want to be able to work together. And we introduced the solution called Ingress Link, or this better together solution, by bringing the best of what BigIP and NGINX can offer. And why? They're very trusted. We've got NetOps and DevOps that are very familiar with the infrastructure. These two platforms are very flexible. They're potentially quite lightweight. This is the great thing. They enable HA, now with DNS integrated into the solution. And so I'm going to talk about external DNS and what it means within this solution. It's just been added in CIS 2.8, which shipped this week. and it is available to you to use, and it is fully supported. And that's where we talk about enterprise-grade security, visibility, and performance. It is all there. With the somewhat of a one common interface, and our goal is to align and to continue to develop this single common interface. I think that's what's really important. And that's my strategy, is potentially to wrap this all into an operator or wrap this into Helm. Because I think just by deploying that will simplify and streamline this process instead of having to download 2 potential repos. So it gets back into building self-service workflows. And this is interesting because building self-service workflows is very persona specific. I see it as more of a DevOps type operation and not necessarily something that NetOps would need to be concerned about. But the infrastructure, the platform has to be there to be able to utilize these workflows and to automate that specifically for DevOps lifecycles. And that's where I think the aligning the priorities and making sure that these platforms are available. So that's really good. I love the questions coming in. Please keep these questions. This is great to see the interactions. If you're not familiar with something, please let me know, and I'm going to go ahead and cover it quite extensively. This multi-tenancy within Kubernetes is actually really interesting. I have recorded in the last couple of weeks some environments that are not only multi-tenancy but are also multi-site. So this solution that we're going to talk about here can be rolled out into a multi-site, multi-cluster, multi-location. How it all ties together is potentially using external DNS. That potentially means you could have one cluster of Kubernetes, you could have another cluster of OpenShift. Your applications could be duplicated or the same. Your configuration is very, very, very similar. Very similar, which is actually really cool. So the ease and flexibility of deployments is really there. And it really is, it really gets back to how do you want to deploy this and what are your priorities between your different groups. So this solution, the Better Together, it's really here to save time. And here's the biggest thing, is reduce errors. I do see quite a few errors with declarative deployments. These systems, they do some validation. We've got schema validation for our CRDs. Yes, that's one aspect. But IngressLink is quite interesting because IngressLink, we've done a lot of the abstraction for you, and we've hidden a lot of what doesn't necessarily need to be there from a configuration perspective because we kind of know what the values are. But there are some items that if you don't input correctly, the solution won't fully work. So abstract away some of the infrastructure knowledge. Also, unify the source of truth. And then, again, we talk about simplification here. We can also use the solution with DNS, IPAM, and WAF. And we'll get into that. So what I would like to do now is go ahead and probe the audience, and I'm going to go ahead and probe this next question. And so I do see a question here. Can you please define what you mean by BigIP? So BigIP is a platform that F5 has released, and so BigIP is F5's, if you want to call it, load balancer, application delivery controller. It is what F5 has been positioning, F5 has been selling for many, many, many years. And this is a device that would front-end your applications. Think of it almost as a full proxy that has the capabilities to do a bunch of things like security and that kind of thing. So here's the question. So are you currently leveraging BigIP today within your environment? And you could be leveraging BigIP for existing applications, maybe not necessarily Kubernetes applications. I understand that. And so in my lab, am I leveraging BigIP? Yes, BigIP is front-ending all of my Kubernetes and OpenShift environments. I build Kubernetes and OpenShift on private networks. I don't expose those IP addresses. Anytime I need to go out and update a container, or I need to pull something from Docker or the Red Hat registry, BigIP does the net. So BigIP is hypothetically in my in my production labs that I do all my testing. Think of it as my Kubernetes Ingress. You could call it as my Kubernetes gateway, Kubernetes firewall, etc. And so that gateway API is actually what's kind of cool for me. That's kind of how I define it. So I'm going to actually go ahead and answer yes here. Let's see if I can get the polling question. So that's interesting. And as you can see, a lot of organizations today are leveraging BigIP. And to be honest with you, a lot of the customers I talk to, they're leveraging BigIP. It's just really how does the different personas, how can I get different teams to interface together? And some of the BigIP owners, BigIP personas, don't necessarily want to allow another tenant to be able to communicate with that BigIP because of potential, maybe it's operational issues. And so let's go ahead and look at that and potentially how do we create a tenant or a specific piece, or how do we virtualize that BigIP so that potentially maybe it could be used for Kubernetes. But that is actually a really interesting question. Let's go ahead and take a look at the other one. So this is a question, and it's really a question because I am a PM and I'm really looking at you folks as the community to determine, are you leveraging CIS? So CIS is BigIP's Ingress controller or container Ingress controller. And CIS has been shipping since around 2016. It's actually quite a while. And what CIS does is it actually is deployed in Kubernetes, but automates or orchestrates BigIP. So think of CIS does the service discovery and then populates BigIP's pool members, and then BigIP is able to forward the traffic into the cluster. So the simple question is, are you leveraging CIS today to automate or provision your BigIPs for your container apps? In my instance, yes, I am. So I'm going to go ahead and answer a simple yes question there. And this is going to be interesting. And you know what, to be honest, this 17 to 82, this is exactly what CNCF tells us. It's around between 15 to 20%. So when we probe and we pull in information from CNCF, which is the cloud body, the formation or foundation, we get that. That's really interesting to take CIS and NGINX for Ingress and put those two numbers together. Believe it or not, it's plus 70%. And I think that's really interesting. So really interesting to see. So this is another question, and this is obviously a big question because NGINX, a lot of people are using NGINX Server. And you could say yes in this case, but are you using NGINX deployments today? And again, this could be NGINX backend deployments. NGINX has a really good NGINX backend deployment. I use it all the time for my demo app, specifically coffee and tea. You'll see it here in this presentation. I really do like it, so I'm going to go ahead and answer yes. I think that there is it's available. You can just really download the backend apps, and then of course you can customize it. But great app to use, and fair enough. That's about a 50-50 split. Or a little bit more there. Don't know, no problem. That's actually really good. So almost there. Really good one. Annotations, and believe it or not, annotations are coming back. We're starting to do a little bit more with annotations, but here's where the annotations are coming. The annotations are coming back in the service. Think about type load balancer. Type load balancer, you just create a service. So a service is how does that application interact with the network, and what is it doing? It basically says, I deploy the service, and my service listens on the following ports, and here's how you get to that deployment. What the service is it tells the load balancer what to do and how to network. We just launched integration with VMware Tanzu, and specifically using the Antria CNI, and all of that configuration is done within the service. So that annotation within the service is quite interesting. I do think that Ingress or Ingress class or Ingress routes or HTTP routes, if you start looking at the next generation gateway API, they're potentially moving away from annotations. We have a lot of objects on BigIP. Can we annotate every single one? Maybe not, but and I think that's where CRDs really come alive. So do you use annotations for Ingress routing resources today? I only use annotations if I'm using OpenShift routes as of current, if I'm not using CRDs. So I'm going to go ahead and say yes. And that's 28 to 20 and potentially 52, maybe not sure. So that's actually a good question. If you do ask that question when you do meet your Kubernetes groups, that's a good question to ask. What type of resource do you configure within Kubernetes to ingress traffic? That's a very simple question. Is it an ingress, Kubernetes ingress? That's one potential. Is it a CRD? Is it of OpenShift routes? And again, there's many of them. There's probably about 5 today. And because this is community-based, this is community-led, not one vendor dictates kind of what goes on here. It's completely the Kubernetes community that kind of works off these. Really good question. So let's take a look at how do we align priorities. Folks, this is a new slide, and actually this is not coming from me. These terms of infrastructure provider, cluster operator, or application developer is now coming from the Kubernetes community. But what I find interesting here is kind of how does the solution line up? And how do we map? And I think potentially, and again, if you want this link, if you just go and look just go look on the Kubernetes site, kubernetes.io, you'll actually find this new doc. And what's interesting is potentially this middle person here, this cluster operator, maybe the new title or new role is of Kubernetes engineer. That person is not necessarily a DevOps or an application developer or an application owner, but that engineer or that person or that persona is someone that is really maintaining, potentially has admin creds that can actually create, monitor, or potentially restart these operators, or if you want to call it these controllers. And so if you look at this environment, we still have 2 controllers. Will we merge this into one controller? Maybe in the future, but definitely not this year. These are still separate dev groups, but these dev groups are very active, and these dev groups are communicating between the 2 teams. And that's the great thing, is that these resources are communicating. And the goal is to have these 2 be able to use a common API. That common API, I think, is quite critical. And so you can kind of see how we broke this out. And so if you look at the solution about how do you deploy potentially BigIP and NGINX together, I think this maps quite well, and I'm going to continue to use this mapping. I'd be interested to see how this aligns with your organization. And again, maybe smaller organizations, maybe one person wears multiple hats. But I'd be very interested to see how this. So infrastructure provider is really your BigIP operators, your BigIP admins. Maybe those are folks that monitor, configure, and administrate the BigIP. That group would need to be in contact with the operator, with the cluster operator, because CIS would be configuring a piece or a portion or an instance of the BigIP. Think of it as a tenant, a namespace, or a project. But what's interesting is that the application developer wouldn't necessarily need to integrate with the BigIP. The application developer would only need to communicate and configure NGINX Ingress controller. These 2 are somewhat decoupled. What's great about that is that if there's an error out here, or if the application developer, think of it, is scaling or auto-scaling a lot of pods, only the NGINX Ingress controller is seeing it. BigIP is completely stable. BigIP doesn't see it. BigIP only sees the NGINX Ingress controller as its pool members. So BigIP is only front-ending the NGINX Ingress controller. If you want to auto-scale your NGINX Ingress controller because of more load, more data, or potentially you want more throughput, then you could go ahead and scale this. Once you scale this, CIS will see it and update the BigIP. So this two-tier architecture is being decoupled. And the reason why is potentially to align with the different personas. I'd be interested to see if this aligns and fits with your organization. By the way, some of these might not exist, but I think that's why this Kubernetes engineer, this new title that I'm seeing, is actually becoming more prevalent. So now that we saw the different personas, let's take a look at what IngressLink is. So folks, IngressLink is a kind of CRD. I say it's a kind because it actually is. It is something that F5 has created as a solution. The two components, CIS and NGINX, are independent. Both of these solutions are fully supported. That means that if you roll this out, if you need F5 development support, you can call into F5 support and you can get full enterprise-grade support. Whatever contract or whatever license you have on BigIP, or CIS inherits that. And so that's one of the reasons why NGINX Plus is important, because NGINX Plus provides you with your support. If you use OSS, that's fine, but that piece is going to be community supported. But the IngressLink piece is fully supported, and I have seen some, if you want to call it tickets, or some GitHub issues, and those are resolved. And this is an ongoing dev project that is maintained by development and funded. So the IngressLink CRD is created, and both of the controllers are able to monitor this IngressLink CRD. So if you think about it, at the end of the day here, we're just using the Kubernetes API, but both of the controllers are able to communicate across this IngressLink CRD. If you want, and I'm going to show you in a minute, if you want to potentially decouple and remove the capabilities of creating the CRD and just use service type load balancer, that's coming. The IngressLink CRD itself is very uncustomizable. It is that cloud-like layer 4 ingress traffic at layer 4 from BigIP straight to NGINX. What is tied in here is BigIP will monitor for health the NGINX liveness port or liveness probe. That means that BigIP will check to make sure that these ports are up. There's a specific API to do that. If one of the NGINX liveness ports is down, then BigIP will remove that from its pool members. How you integrate from a CNI here is really up to you. You can use Calico. You can use VXLAN. So the two traditional options is Calico, which is a BGP based. You can use Flannel or VXLAN. And then if you want to just do routing, you can also do that with potentially something called node port. So either option, node port, cluster IP, those are your two options. And potentially now node port local, potentially, if you want to use that as well for VMware. Those are your options as well. So once the CRD is created, what CIS will do is it will populate BigIP with these pool members. What's really great is we talked about this. Anything that's going on here is outside of what goes on here. So this one instance, BigIP, will have 3 instances here. When the application developer brings on new services, they're creating a separate resource. The separate resource is of a different namespace, is potentially of a different project. CIS doesn't pick it up. CIS doesn't watch it. and that's really interesting. This is all watched by the NGINX Ingress controller. So all HTTP routing is done here. This is potentially end-to-end SSL. So SSL all the way through. And then at the back end here, potentially you could do clear text if you wanted to. That's a configuration of the NGINX Ingress controller. So two personas. So the cluster, if we go back to the personas in this case here, the infrastructure provider is really out here. The cluster, the cluster operators are really sitting right here. Cluster operators are right here, and the application developers are back here. So here is an example of the IngressLink CRD. You can see this is a kind of Ingress Link. This is specifically written. This is in both of the API specs. This is also within the schema as well. The only thing that you really need to do is name it. Try to keep the namespace the same. It's actually just easier for yourself. Provide a IP address. If you don't want to provide an IP address, you can use IPAM, and that's perfectly fine. If you want to use proxy protocol, you can. You don't have to. And the name here is really important. This is the name for Kubernetes. This name will change for OpenShift, because for OpenShift it will be NGINX Ingress Operator. So just replace the name if you're using OpenShift. So what will happen is once you create this within Kubernetes, this is like 11 lines. Once you create these 11 lines, what will happen is CIS will populate BigIP. I know this is a little bit blurred. I do apologize. I pulled it out of the docs. And I do have this all written up. This is all written up. There's a GitHub repo. You can clone the repo. I will share that at the end of the slides. This is what will happen is this will be, pool members will be created, and you can see the pool members here. There's 4 replicas, and that's the proxy protocol. Again, this is all in the documentation that I will share at the end. So to go even more simpler, what we're going to do here is we're not going to deploy that CRD. We're going to simplify this even more. So we talked about the CRD here. In this next step, we're not going to deploy the CRD with an IP address. We're going to use something called service type load balancer. This is very common in cloud today, where the cloud provider provides the ingress and creates the service type load balancer. Now, how do we do this? We simply annotate the service. So it's exactly the same architecture. The only difference is the cluster operator doesn't necessarily need to create the CRD. The CRD is created for you by IngressLink itself. And so let's take a look at what that looks like. So what you can see here is everything is created through the service. And this is the NGINX service that CIS is watching. CIS is subscribed to the service. Think of this as CIS's endpoint. And so we watch this endpoint, and we pull all the information from Kubernetes on that Kubernetes API to populate this endpoint. The difference here is of annotation, IPAM, test. Test, think of it as a label. So think of what test is, a range of addresses. And you can have many different ranges. This could be one IP, this could be a group of IPs. It's just a range. And so what happens here is that we specify this IP range, and we specify type load balancer. And what will happen is the IPAM controller will get and allocate an IP and update the status of that IP. So you can see right here, my IPAM label is of test, and that is the service, and there is that IP address. And this is stored in the IPAM controller. This is the BigIP IPAM controller. This is, again, fully supported. It can also be downloaded as well and utilized with the solution. So this really simplifies the solution, because the only thing you have to do is create the annotation and set up the IPAM controller. And that is kind of what you see right here. CIS interacts with IPAM. There's nothing you need to do here because the service is created, and that information would automatically get populated to BigIP. So this is the last solution. This is the last solution here. And this is really a question around what we talked about earlier. And this is something that we just released with CIS 2.8, and this will work with the latest version of the NGINX Ingress controller as well. And so I know there's a lot going on here, but our goal is to think about it, is to leverage potentially BigIP DNS as well. And so this is where we're starting to really start to think about this solution. And this solution is totally going to evolve. We're having a lot of meetings internally. I am talking to a lot of customers across the United States. We're doing a lot of big room planning and a lot of meetings, both in Europe as well as Asia Pacific. And what's coming is actually some similar type of priorities for the specific use cases. In fact, I've got 5 use cases that I'm going to start pushing, and I've already started to scope the first 2 out for the next 2 up-and-coming releases. And let's talk about that. So in this instance here, I have now introduced DNS. And so we have our Ingress CRD that we talked about before. So think of the Ingress CRD as really the communication into the Kubernetes or OpenShift cluster. And so that's what you see right here. So that potentially is created by the cluster admin or the cluster operator, that Ingress CRD. So now we have what I call local traffic management, or we have a public IP. Think of it as a virtual IP that is sending traffic to a big IP pool. And within the pool, we have 3 pool members. That's great. Well, now I have rolled this out, let's say in San Jose, California. But now what I want to do is I want to roll out another cluster. Maybe it's a cluster that is in a different cabinet. Maybe that's the latest version of Kubernetes. Maybe this one version was 119, and I rolled out a version of 123. And what I wanted to do is I wanted to mirror these applications, but I didn't necessarily want to upgrade. Or if I did want to upgrade, I didn't want to take my environment down. Or maybe I'm doing a proof of concept with Kubernetes, but I wanted to do another proof of concept with OpenShift, and I wanted them to work side by side to kind of determine what do I like better. Maybe it's Rancher. Maybe one is a Kubernetes cluster on-prem, and the other one is a Kubernetes cluster that's hosted in your cloud provider. It really doesn't matter. This architecture right here is completely platform agnostic. But the key here is to integrate external DNS and to utilize BigIP DNS that a lot of customers are already utilizing today. And so that means that CIS will create the wide IP on BigIP DNS based on the availability of the applications. For CIS to be able to do that, CIS has to monitor and probe. You might ask me, why do we have to probe when we know the status potentially of the service? Well, this system is currently decoupled. CIS doesn't necessarily know the status of the services without the monitor. But where we want to go, and this is where we want to go, is to find these services and push that information through Ingress Link so we can populate them both out here without having to do all of these monitors. And the only reason for that is it scales really well. However, there are many customers today doing DNS monitors. And this could be a monitor using HTTP or HTTPS. And we also do what we call SNI monitors. I know that's a little technical. It's a feature that started in BigIP 16.x. We can talk about that later. But that is the current solution. Folks, this is currently shipping today. You can deploy this today. Everything that you see on the slide is 100% fully supported. So let's take a look at how do I architect this. Now I've created a repo that you can clone and that you can configure. You can pull these examples. So we already talked about the first option of using Ingress Link. We already talked a little bit about this and some of these options. But one thing that's new here is this host. So this host is, if you go back to the diagram, the host is your wide IP. And this is the answer for the site. So think of it, if you have two sites, San Jose and maybe let's sort of Seattle, I'm going to have one wide IP, but BigIP is going to be delegated for that one wide IP, cafe.example.com, but I'm going to have two pool members. I am either going to give out either A site or B site. And in this environment here, I'm going to load balance between A and B. So highly recommend go back and look at my YouTube channel. And with my YouTube channel, you will find this. There is a video of this exact solution using this exact CRDs where I am load balancing between these two locations. One cluster is Kubernetes, the other cluster is OpenShift. What's really nice is that I can actually take down the services. So in this instance here, I can actually replicate these to 0 or scale these down to 0. The wide IP is removed. Completely removed. That means that now I mitigate and I move traffic. So you might say, okay, well, that's great, round robin is fine. What about other types of operations? In 2.9, we have one story that is already written up. This is the highest priority that came from a workshop over in Europe where they want to do ratios. And the ratio is potentially, think of it as an A-B type split, where maybe the ratio is of 10 to something else. And so this is what we want to do here for site A. This is site A here, Kubernetes. Maybe this is a ratio of something. And site B has a different ratio. GSLB will take care of that. The API is already there. It's really just adding information to the external DNS schema. And then CIS will populate, or CIS will automate that function. So this is of external DNS. Here the namespace that we're monitoring is Ingress, NGINX Ingress. There is your domain name of a type. This is an A record, simple answer, of round robin fashion for this data center name. So this has to be known. And here are my monitors. I want to monitor both sites. I'm also using iQuery Mesh here. Also, at this current time, we're using both BigIP load balancing and DNS together. I am having discussions, and we're potentially looking at building a business plan to only do DNS and maybe not the load balancing. There are some organizations that just want the DNS piece. Later in the year, we're starting to look at that solution. So if you look at what this looks like, you can actually see the CRDs here. You can see there are the IngressLink CRDs. This is the specific service. This is the virtual server here. And you can see here is the external DNS service. And so here is your wide IP. I do apologize for the graphic, but please go ahead and look at the doc. And you can see here's the wide IP. You'll notice there's two pool members in there. There's the two pool members. And if we actually look at that architecture, we can actually see what that actual architecture looks like. So here is what I kind of want to finish off before I start jumping into questions. Folks, I know this is a lot right here. But think about it. We're utilizing a solution that is fully supported. I have provided, or I can provide already, a GitHub repo that has all of this built where you can clone it. There is YouTube videos as well with step-by-step documentation on how to do this. And so we've kind of come a long way. We kind of talked a little bit about this first. Now we added DNS piece to this. And now think about it, we've added multi-cluster. And again, this could be anything. It could be Rancher with something else. It really doesn't matter at this point. As long as it's something that that CIS supports or is CNCF based. I think that's what's really more important. So I am really interested to get some feedback if this kind of works for you. I do have an example here. Remember I talked a little bit about there's not a lot of changes between the two. There's really only 2 changes between OpenShift and Kubernetes. This is the 3 put together. This is the application virtual server that specifies the application. I am doing full end-to-end TLS, or what we call re-encrypt, and here is my external DNS. So between these two groups here, 121, you'll notice this is the virtual IP for OpenShift, and you'll notice here, this is what's different. Other than that, folks, it's exactly the same. So you'll notice that this is 121, this is OCP. If we go to Kubernetes, different IP, different data center. If we go back, you'll notice different IP, different data center. Other than that, it is exactly the same. And that is really the simplicity that I think is what's coming in here. Oh, it is a little different on the service. My mistake, because I am using in OpenShift to do NGINX Ingress controller, you have to run the operator. And so the operator is different. So if we go back one level here, we can, oops, my mistake, let's go. Oh, I need to fix this. Do apologize. Yep, that's the controller there. So, in any case, that's why you always pull from source of truth, right? Pull from source of truth. I copied these slides. Always pull from source of truth. It's really important. So, where are those videos? So, I'm not sure if you can see these links. I can't click on these links in here, but to gain access to the YouTube videos, please go ahead and pull this YouTube video right here. You can also take a look at my GitHub page. All of the user guides that I talked about are here. So if you take a picture of this, or if you just go and search for me on GitHub, you'll find this on YouTube as well. You'll find also these YouTube videos are posted on F5 Dev Central as well. But you will find it here. You can also, believe it or not, if you actually find an issue, you can actually file an issue. I'll actually fix it. Or if you want to commit, I'll actually accept the contribution. But if you look here at these user guides, you can literally pull the source. And so that's why it's way better, because that source of truth is way better than pulling it from a slide.